share. Okay, we will continue a bit from your textbook. Okay, we don't write the index first. Okay, so this one you just continue. Actually, this one I plan to finish it yesterday one. Okay, can see my textbook?
Can see, teacher.
Okay, thank you. Okay, so we go to this example. Okay, this example they didn't mention the how to say the ratio. Okay, expressively means they just say out for you to know what is the ratio. Here, they say is about the velocity, and then they tell you that the time, okay, that actually represent the ratio. Okay, so we go through. Okay, a spider is at positions E, -7, -5 on the graph paper and move towards a point G, 13.5 along a straight line with uniform velocity. So means the velocity is the same. Okay, so means the movement is not speed out. Okay, you have a uniform speed means the speed is always the same. Okay, so the spider is at point P. Okay, after moving for 18 seconds. After 18 seconds, it moved from E to P. Okay, so this is from E to P. Okay, and arrives at point G in 1 minute. So this in 1 minute, it actually is means it start from the E, okay, and then arrive at G in 1 minute. Okay, so you have to read carefully. This 1 minute is not means is from the P to G. Okay, okay, is from the original, okay, the position which is E, okay, to G. Okay, the spider took 1 minute, okay, to arrive. Okay, so it's from the E, not from the P. Okay, so if you draw out in a graph or Cartesian, okay, it will be something like this. Okay, so it start from the point E, then go to point P, after that go to G. Okay, so after move for 18 minutes, 18 seconds, okay, the spider is from E to P. Yeah, after move for 1 minute, the spider from E and then reach to G. Okay, so this one will give you the ratio. Okay, so you see E to P is 18 seconds. Okay, then E to G is 60 seconds, which is the 1 minute. Okay, must change into a same unit for ratio. Then after that simplify, so you get 310. Okay, E to P, this is 3, and then E to G, this is 10. Therefore 10 minus 3, okay, the P to G is 7. This is how you analyze the question and get the ratio. Okay, so this question is a bit spatial Okay, so now we answer the questions. They want you to find the coordinate of point P. Okay. Okay, so same thing, you do cross. Okay, so the 7 cross with the point E, then 3 cross with the point G. Okay, so the point P you can straight away write in a coordinate form. If not, you do like previously, you get the X coordinate and then the Y coordinate also can. Okay, so 7 times -7 and then 3 times 13 for X coordinate. Okay, 7 times -7 plus 3 times 13. Okay, and then the total ratio is 10. Okay, for Y coordinate, 7 times -5 and then 3 times 5. 7 times -5, 3 times 5. Okay, then you get the coordinate. Okay, this is part A. Part B, okay, they want you to find the ratio EQ. Now Q is another point. Okay, QG. Okay, when the spider is at point Q. Okay, Q is 11,4 on the straight line. So you draw another one. Okay, don't let the point P disturb you. Draw another graph. Okay, so the E and the G remain. Okay, don't show the point P anymore because this question got nothing to do with the point P. So, but you have a new point here, which is point Q. Okay, 11,4. Okay, so they want to know what is the ratio EQQG. So you can label it as a M and N. No? Okay. So this one, same thing. You don't have to find the M. You don't need to find the N. You just need to find M over N. Okay, the ratio. Okay, I think previously also you have a question something like this. Okay, so you just either use a X or the Y coordinate. Okay, for these 3 points. Okay, here I think they are using the Y coordinates. Okay, so same thing. We do the cross. So N. Okay, cross come to the E, and then M cross come to the G. Okay, and then let it equal to the Y coordinate of the point Q. Okay, or take the Y coordinate. So negative 5 times N. Okay, negative 5 times N. Okay, and then 5 times M. 5 times M. Okay, and then over the total, what's that? The total ratio M plus N. Okay, and then equals to the 4. Okay, the Y coordinate of the internal point. Okay, so you solve it. Okay, you get the M over N is 9:1. Okay, so this is the answer. Okay, so this is the example. Okay, so this is a today homework. Okay, so before I go to next subtopic, this one don't need do. This one don't need do. Okay, this one we can leave it, when we do revision time. Okay, this is the next subtopic I want to do today. But before that, I want to go through with you that one. Okay, I hope you have print out and then you have stick in your book. Okay, yesterday I put in your WhatsApp group. Okay. Okay, this is the one. Okay, midpoint of the diagonal of a parallelogram. Okay, this one you must know. It's very useful. Okay, when you solve this topic, the questions related to a parallelogram. Okay, so you see this. Okay, this one is the proof. Okay, for this afterwards you have a one statement. Okay, consider the parallelogram ABCD. Okay, and then all the points are given. Okay, so first they want to they find the midpoint of a BD. Okay, means the midpoint of the diagonal. Okay, BD. Okay, and then next they find the midpoint of the diagonal AC. Okay, and then it's proof that their diagonal, their midpoint are the same. Means the midpoint of the diagonals of a parallelogram, they are the same. Okay, they fall at the same point. Okay, the above show that the diagonals BD and AC bisect each other at point M. Okay, that is the midpoint of a BD is the midpoint of AC. They are the same. Okay, this result hold for any parallelogram. Okay, then we see. Okay, it some more continue to define what is parallelogram. Okay, note that rectangles, rhombuses, and squares are spatial parallelograms, and their diagonals bisect each other. Because these three are parallelogram, therefore it follows these rules also. Okay, the diagonals bisect each other. Okay, that is the diagonal have a common midpoint. So this is um, how to say a theory of that you can use. Okay, when next time you solve any question related to a parallelogram, okay, we look at the example how we use this point, okay, to solve the problem. Okay, you see this PQRS. Okay, now 3 points are given. Okay, the fourth point or the fourth vertex is not given. Okay, the coordinate. Okay, so this is a parallelogram. Okay, so I can use a rules just now. Okay, first find the midpoint of the diagonal PR. Okay, so this is actually guided you. Okay, so you find the midpoint of the PR. You stick already or you copy already, then this one you can write out the solutions. Okay, I will do it here. Can I write? Okay. Okay, so part A. Oh, what's happening? Okay, I know already. Maybe my cursor. Okay, wait. Okay. Okay, part A. So we find the midpoint of a PR first. Okay, so midpoint of a PR. Okay, PR will be the diagonal. Okay, so P is 4 for the x coordinate, and then R is -2. Okay, so divide by 2 for midpoint. Now is the y coordinate -4 and 4. Okay, divide by 2. So this is 4 minus 2 is 2. 2 divided by 2 is 1. Okay, 4 minus 4, 0. So this is 1, 0. Okay, now we go to B. Okay, the coordinates of the last point, okay, or the last vertex. Okay, parallelogram 4 points. Okay, 1 point don't know the coordinates. Okay, so if the questions they don't want to guide you, actually they will not ask you to do part A. They will straight away ask you to find the coordinate for the points S. Okay, so actually these questions you want to find the coordinate for point S, it can be done by using other ways. Okay, you can use the gradient methods, other methods, but I think these methods will be the easiest one. But it's just the problem, can you remember these rules or not? Okay, or this theory or not? Okay, so the midpoint of the PR, the diagonal, okay, is same as the midpoint of the QS, okay, the other diagonal. Okay, so you can write midpoint of QS is equal to, okay, midpoint of, okay, PR. Okay, PR. Okay, so midpoint of QS, okay, you can let the S be XY. Okay, then midpoint of a QS 9 and 6. Q is 9 and 6. Okay, so you write it out. 9 plus X divided by 2. Okay, then 6 plus Y divided by 2. Okay, then equals to midpoint of a PR. PR is 1, 0. Okay, this is the answer from part A. Okay, then you solve one by one. Okay, so for the X coordinate, okay, let this equals to 1. Okay, then you solve for the X. Okay, so 9 plus X is 2. So 9 is 2 minus 9 is -7. Okay, then you solve for the Y coordinate. 6 plus Y over 2 is 0. Okay, 2 times 0 is 2. As 2 times 0 is 2. 2 times 0 is 0. Okay, and then Y is -6. Okay, I hope I didn't make mistake. Okay, therefore the point S is x is a -7, y is a -6. Okay, so this is the answer. Okay. Okay, so this one, the solution you write. Okay, if now you tak sempat copy, then after you see the video again. Okay, so now I want to go to the next subtopic already. Okay, parallel line and perpendicular line. Okay, we'll come back here. Okay, you write the index for today. Okay, parallel line and perpendicular line. Okay, today is 2nd of July. Okay, this activity I don't do. Okay, I will straight away go to this. Okay, this is a formula for gradient. I think this one you have learned before. Okay, and then this is another formula for gradient. Okay, gradient is also equals to a tangent theta. Okay, theta is here. Okay, we will see how they get the gradient also is equals to tangent theta. Okay, you have learned this tangents. Okay, this is a right angle, triangle. Okay, tangents, tuakaso, you have learned this or not? Okay, so tangent is tua. Okay, ka is a cos. And then so is a sine. Okay, so tua means tangents is equal to opposite side over the adjacent side. Okay, if this one you forgot already, you got to do revision by yourself. Okay, so here is the theta. The opposite side is the one opposite with this angle theta. Okay, so here is the opposite side. Okay, and then the side opposite with the right angle, this is hypotenuse. Okay, and then the other side, okay, the last one is adjacent. Okay, so if you look at this diagram, okay, you have a point A and the point B. Okay, point A you label the coordinate as a x1, y1. Point B you label the coordinate as a x2, y2. Okay, if you use the gradient formula, okay, y2 minus y1 over x2 minus x1. So the y2 minus y1 actually is the vertical distance in between the 2 points. Okay, then the x2, x1 is the horizontal distance in between the 2 points. Okay, so you will see actually if you label here as a theta, okay, this theta and this theta the same, okay, because this is parallel to the x-axis. Okay, so if you look at this diagram, okay, the theta is here, therefore this is the opposite. Okay, and then this is the adjacent. Okay, so the y2 over y1, y2 minus y1, this is the opposite. Okay, and then x2 minus x1, this is the adjacent. Okay, therefore the gradient also is same as tangent theta. Okay, I think this is new for you. Okay, this one you can copy. Gradient is equal to tangent theta. Okay, maybe you copy this. Okay, with theta being the angle formed between a straight line and the positive x-axis. Okay, means we take this way. We don't take this way. Okay, if negative x-axis will be this way. Okay, so positive x-axis we take this way. So the straight line and the positive x-axis, this angle we label it as theta. Okay, and this theta is in between 0, okay, smaller than 180. Okay, we don't have a more than that. Yeah. Okay, after you copy this as your notes, I want you to copy this one as well. Okay, this 4 diagram, 1, 2, 3, 4. Okay, we will see. Okay, first of all, we have a vertical line. If the straight line is not slanting line, is a horizontal line. Okay, what will happen to the gradient? Okay, and then what will happen to the tangent? Okay, so you see, if the line is something like this, the angle is 0, the theta is 0. Okay, then you press the calculator, tangent 0. Okay, I can call on my calculator. Okay, so tangent, okay, now the angle is 0, the theta is 0, okay, so it's 0. Therefore, the gradient is 0 because now we know already the gradient is tangent theta. Okay, so this is for horizontal line. Okay, now we go to vertical line. Okay, vertical line, the theta is 90 degree. Okay, so we get tangent 90 degree. This one will be the gradient. Huh? Okay, max error. Okay, means this is not defined. Okay, so the gradient is not defined. Okay, some you will write infinity, but here we will write not defined. Okay, next, for the theta is in between 0 to 90. Okay, not include 0, not including 90. Okay, here the tangent theta is positive. Okay, therefore the gradient is positive. You can put any. Okay, as long as the angle is in between the 0 to 90. Let's say I put 50. You will see the tangent give you a positive value. So the gradient is positive. But this one also you know, okay? Okay, if the slanting line is this way go up, the gradient is positive. If the slanting line is this way come down, okay, the gradient is negative. Okay, we also want to prove it, okay, by using the tangent theta as the gradient. Okay, if okay, the slanting line coming down like this, you see this theta is bigger than 90 degree. Okay, this angle is bigger than 90 degree. Okay, but it's capped at 180 degree. Okay, not equal and then not more than 180 degree. Let's say I put 120. Okay, let us see. Tangent 120 will give you negative or not. Okay, negative. Okay, you can put another one. Okay, let's say tangent 150. Okay, it's also negative. Okay, so these four I want you to copy also. Okay, we go to next. Okay, this subtopic actually we want to see parallel line, okay, and perpendicular line. Okay, now we come to parallel line. After you know that the gradient of the line also can be a tangent theta. Okay. Okay, now you look at these two lines. Okay, L1 line 1, okay, L2 line 2. Okay, these two are parallel. Okay, if these two are parallel, okay, the theta 1 and theta 2, the angle also is the same. This one you have learned during your lower form, corresponding angle. Okay, corresponding angle are the same. Okay, so theta 1 is equal to theta 2. Okay, if theta 1 is equal to theta 2, okay, tangent theta 1 also will equal to tangent theta 2. Okay, then if tangent theta 1 is equal to tangent theta 2, then m1 is equal to m2. Okay, let the m1 will be the gradient of L1, m2 will be the gradient of L2. Okay, so this is proof, okay, by using the concept of corresponding angle and gradient as equals to tangent theta. Okay, so this one I want you to copy. Okay, two straight line L1 and L2 are parallel to each other if and only if, okay, M1 is equal to M2. Okay, if and only if have this meaning. I think your chemistry you learn. Okay, if and only if, or your modern maths also will learn. Okay, they have a this type of meaning. Okay, number one. Okay, if L1 parallel to L2, then M1 is equal to M2. Number one. Okay. Number two, if the other way around, M1 is equal to M2, then L1 is parallel to L2. Okay. If and only if they bring this meaning. Okay. If you don't know, I don't know whether you have learned this before. I know your chemistry. I know your modern maths will learn. Okay. So when you see if and only if, okay, it's a two-way the meanings. Okay. If, then. Okay. Another way. Okay. From the back come to the front. Okay. If, then. Okay. So this is for parallel line. Okay. Now we come to this perpendicular line. Okay, for perpendicular line, I want you to look at this. Look at this one. Okay, look at this one. And then you can look at this diagram also. Okay, how they prove that m1 times m2 is equal to -1. Okay, this is the final conclusion we have. Okay, but before that, how they prove it? Okay, first of all, you say, look at this triangle ABC. Okay, and then tangent theta 1. Okay, theta 1 is here, and this is 90 degree. Okay, tangent theta 1. Okay, they use the Tuakaso one. So this is opposite over adjacent. Okay, let me see. Where is the opposite? If the angle is here, opposite is here. Okay, so AC is the opposite. Okay, adjacent is here. Okay, BC is the adjacent. Okay, so tangent theta 1 is equal to AC over BC. Okay, this is a first step. Okay, after that, okay, if you write the other way around, okay, BC over AC. Okay, BC over AC, this one terbalik, so this one will become 1 over tangent theta 1. Okay, then you put aside. Okay, now we see what happened to this tangent theta 2. Okay, tangent theta 2. Okay, you see here, theta 2 is here. Okay, this theta 2 actually you can see the corresponding angle is here. Okay, this one you didn't learn yet. How do I say? BCAC. BCAC. How do you know BCAC? Okay, this one you will learn during your Form 5, your modern maths and then your M-maths as well. But here I will just explain to you lah. Okay, this angle and this angle, we will say is a corresponding angle. Is because this corresponding angle is different from the corresponding angle of the just now the parallel line. Okay, this corresponding angle, this one will make 180 degree. Okay, means this theta 2, you can say the corresponding angle of this theta 2 in the first quadrant is this angle. Okay, so if this angle, okay, you want to find the tangent, okay, the opposite will be here, BC. Okay, then the corresponding will be AC. So they write BC over AC. But, okay, because theta 2 is at the second quadrant, bigger than 90 degree. So you have to put a negative. Okay, so if I label this as alpha, okay, tangent alpha is equal to BC over AC, positive. Okay, then tangent theta 2 is negative, okay, of the tangent alpha. Okay, so with a negative only, this is the difference. Okay, where, okay, alpha plus theta 2 is 180. Okay, this one you're going to learn from 5. Okay, I don't think so your lower form you learn this lah. Okay, but because I need to prove it, so I will just touch and go. Okay, you just have to notice. Okay, so tangent theta 2 is equal to negative BC over AC. Now you see BC over AC is this. Okay, okay, so you replace the BC over AC with 1 over tangent theta 1. Okay, therefore tangent theta 2 is equal to negative 1 over tangent theta 1. This one. Okay, then you move this one to this side. So tangent theta 1 times tangent theta 2 is equal to -1. Okay, replace the tangent theta 1 with m1, replace the tangent theta 2 with m2, then m1 times m2 equals to -1 for perpendicular line. Okay, this is the proof for the perpendicular line. The gradient, okay, the products of their gradient is equal to -1. Okay, so all the proof I need to go through with you, even though for some of you, you will feel this is tough, but I still need to go through with you. Okay, it just we just afraid, you know, the new syllabus, they will ask for proof. Okay, so this is the second one that you need to copy now. Okay, after the just now the what to say, the parallel line. Okay, two straight line L1 and L2. Okay, are perpendicular to each other. If and only if, you see, again this sentence, so it's two-way, okay, m1 times m2 equals to -1. Okay. Okay, now we want to see how we apply these two, okay, into the questions. Okay, look at example 5. Okay, show whether the straight line, okay, these straight line are parallel or not. Okay, you want to show these two are parallel or not. Okay, you got to show their gradient are the same. If the gradient are the same, then they are parallel. Okay, this is what we learned just now. Okay, so I need to find their gradient. Okay, you just need to rearrange them, okay, into a gradient form, which is y equal ms plus c. Then you will get the gradient. Okay, if not, you can do other ways. Okay, for the first one, I will prefer, you know, rearrange them into the gradient form, which is y equal ms plus c. Okay, so we start. Okay, the 6x move to right hand side, so become -6x. Okay, then because y equals to mx plus c, so the 9 I don't want, so divide 9 with every terms, divide 9. Okay, so you will get this. Therefore, the gradient, okay, the m here is this, -2/3. Okay, this is for the first equation, the gradient. Okay, for the second equations, the gradient, I don't want to rearrange them. Okay, but I can use a formula, okay, for gradient equals to negative y-intercept over x-intercept. Because this is already in intercept form, so it's easier I get the data here. But if you want to rearrange them into y equal ms plus c, also can. But maybe a longer way lah. Okay, so the y-intercept is 2, x-intercept is 3. So 2/3. Okay, so this is the gradient. Okay, compare and see. They are the same, therefore they are parallel. Okay, so this is for question A. Okay, now we go to question B. The straight line, okay, y equals to 4 minus k/3x, okay, such that k is a constant, okay, is parallel to the straight line, okay, the other equations. Find the value of k. Okay, this question means this and this, they are parallel. Okay, so they want you to find this k. Okay, if the question tell you they are parallel, means what? Means their gradient are the same. Okay, so this is the other way around already, you see, okay, so their gradient are the same, so you need to compare their gradient. Okay, for this, the first equations, you just need to rearrange them. Okay, y equals to mx plus c. Okay, therefore the m here, the gradient is this. Okay, -3/k. Okay, this is the first equations, the gradient. Okay, for the second equation, 2x plus 3y equals to 9. Okay, you just rearrange, okay, in gradient form. Okay, y equal ms plus c. Okay, so 2x move to right hand side, -2x. Okay, divide by 3 every terms. Okay, so this is the gradient. Okay, for the second equations. Okay, then because they are parallel, so you can let the gradient be the same. Okay, so -3k/3 is equal to -2/3. Therefore, k is 2. Okay. So this is how you apply. Okay, just now the theory. Okay, now we go to this example 6. Okay, determine whether straight line, okay, y minus 3x equal to 5 and 3x plus x, 3y plus x minus 12 is equal to 0 are perpendicular. Okay, just now we have settled the parallel. So now we come to a perpendicular. Okay, so they want to know whether these two are perpendicular or not. Okay, how to know whether these two are perpendicular or not? Okay, we have to find their gradient. Okay, m1, if you find the gradient, the product of the gradient is equal to -1, then they are perpendicular. Okay, so you have to find the both line the gradient. Okay, you just need to rearrange them. Okay, so for the first line, negative 3x move to the right hand side, become positive 3x. So the gradient is here. Okay, y equal to mx plus c. So this is the gradient. So the first equation, the gradient is 3. For the second equations, okay, first of all, you move the positive, okay, the plus x or the positive x to the right hand side, become a negative x, and then minus 12 become plus 12, okay, and then you don't want the 3, divide 3 by, every terms divide by 3, okay, so this is the gradient, okay, negative 1 over 3, okay, and then if this, you want to prove whether this is perpendicular, you got to multiply both gradient. So you do 3 times negative 1 over 3. Okay, then you get negative 1. Okay, if the products of the gradient is negative 1, then you can make the conclusions they are perpendicular. Okay, now we go to B. Okay, the vertices of a triangle ABC. Okay, C, the y coordinates don't know. Okay, they label it as a k. Okay, k is a constant. Okay, find the value of the k if angle ABC is 90 degree. Okay, so you roughly sketch out. Okay, angle ABC is 90 degree. Okay, here is 90 degree. Okay, if here is 90 degree means AB, okay, BC, how to say, they are perpendicular. Okay, if AB, BC, they are perpendicular, means the gradient of the AB, okay, times the gradient of the BC, okay, you will get negative 1. Okay, so this is how you start. Gradient of AB times gradient of BC equal to negative 1. Okay, so gradient of AB, you use a y2 minus y1 over x2 minus x1, okay, to get it. Okay, so gradient of BC, the same thing. Okay, use the same formula. Okay, and then you solve it, you will get the k is 4. Okay, so this is example 6. Okay, this one will be your another homework. Okay, we look at these questions, example 7. Okay, you have a root ADBC and then EF. Okay, ADBC perpendicular to each other. They meet at the traffic light junction. Okay, BCEF parallel to each other. If BCEF parallel to each other, okay, and then BC is parallel to AD, actually EF also will parallel to AD. Okay, but I think they didn't use for it okay, given the coordinate of A is this, okay, coordinate F is this, okay, the equations of the root BC is this, okay, so find the equation of the root EF. This is why I asked whether you know how to form equation, you know how to find gradient, all that, okay, because you need to use it, okay, for this subtopic, okay, even for the whole topic. Okay. Uh, okay, so A, you have this point, the coordinate, and then you have this BC, the equation of the line. Okay, let us see. Is it this one? No. No, not this. Okay, they didn't draw it up. So if I want to draw it up, okay, I will draw up in this way. Okay, I straight away go to here. Okay. AD, BC, EF. Okay, A is here, 18, 16. Okay, F is here, 20, -1. Okay, I know BC. Okay, this is BC. The equation is, okay, so now they're asking for EF. Okay, EF is this. Okay, so EF is parallel to BC. If they are parallel, okay, their gradient are the same. So you need to find the gradient from the line BC. Okay, rearrange into gradient form. Okay, so this is the first step. Okay, so you see, rearrange in gradient form. Okay, so you get the gradient. Okay, from BC. Okay, this gradient will same as the gradient of EF. Is because they are parallel. Okay, so the gradient of the EF also is the same, -4/5. Okay, you have the gradient already. Okay, then you have 1 point. So you can find, you are able to find the equations, okay, of the EF, okay, by using the formula y minus y1 is equal to m, okay, x minus x1. Okay, so here is the x1, and then this is the y1. Okay, so substitute, and this is the gradient. Okay, and then rearrange. Okay, so this is the equation of the root of EF. Okay, so this is part A. Now we go to part B. The equation of the root of AD. AD is which one? Okay, this is D. Okay, so AD is a one parallel to perpendicular to BC. Okay, so same thing, we make use of the BC, the gradient of the BC. Okay, so the gradient of the BC is -4/5. Okay, so you let -4/5 times the m2 equals to -1. Okay, to get the m2, okay, good gradient of AD. Okay, so this is the gradient of the AD. Okay, so same thing for the AD, you have the point A. Okay, then you use the just now that formula, y minus y1 equals to m x minus x1. Okay, now your x1 is this, your y1 is this. Okay, and then use this gradient. Okay, then you will get the equations of AD. Okay, then we go to part C, the coordinate of the traffic light. Okay, traffic light is AD and the BC. AD and the BC. So this is an equation of the AD, okay, that you get from the part B, and then this is the equation of the BC, that is from the questions. Okay, you want to find the coordinate, you got to solve simultaneously. This one you got to know lah. Okay, so by solving simultaneously, you get the x and you get the y. Okay, then this is the coordinate for the traffic light. Okay. Okay, after this one, okay, you do this exercise, these two questions. So altogether today we have 3 exercises. Okay, I think it's enough for you. Okay, so this one no need yet. Okay, and then same thing. Okay, today I will put in your WhatsApp group. Okay, after you do the exercise, okay, then you print out and stick, same like yesterday one. So today one I will put this midpoint theorem. Okay, also something I think is useful. Okay, you have a theorem called midpoint theorem. Okay, so you can print out and then stick in your book. Okay, for those got no printer, sorry, you got to copy lah. Okay, if you are copying, you can actually make short notes lah if you don't want to copy the everything. Okay, I think that's all for today. Okay, any question want to ask? I have finished another subtopic.